This is GCSE Maths. We're in Unit 18 in the accelerated bit, and we're looking then at histograms. So first of all, drawing histograms. In a histogram, it's a bit like a glorified bar chart, but it's not the height of each bar. The area of each bar represents a frequency. The data is scaled on a continuous scale along the horizontal axis. You would have seen that in the previous chapter. If it was continuous data along the bottom instead of different groups, you know, like 0 to 6 or 6 to 16, it just goes 0, 1, 2, 3, 4, 5, 6, 7, 8, and it's just a continuous scale going along. Frequency density is plotted on the vertical axis, and frequency density we calculate by doing frequency over the class width. Data can be represented in two different ways. Obviously, groups like this, 1 to 5, 6 to 15. In this case, the class width, so this is the size of each group. So the class width in this case is then going to be from 0.5 to 5.5. It's the kind of cutoff in between the 5 and the 6. Do you see that? So that's your 5.5 there. And the size then of this group is 5.5. Take away 0.5, which is 5. The next group, then the next group would obviously start at 16. So the cutoff here is going to be 15.5 and here 5.5. So we would do 15.5, take away 5.5 then, which is 10. So the class width is always the upper boundary, and these are the boundaries here. Take away the lower boundary. In this sort of case, so this is 1 to 5, 6 to 15. In this sort of case, it's actually a bit easier to work out. In a histogram, the class width is not always the same. 0 to 6, 6 to 16. In this case, because there's no gap in between 6 and 6, obviously, we just do 6 take away 0 to get our 6 here, and then 16 take away 6 to get this. So to draw a histogram, we work out the class widths for each group. We calculate the frequency density for each group. We plot a continuous scale on the horizontal axis. We plot a frequency density on the vertical axis, and then we draw our bars. So let's take a wee look then at our first example. For example 1, a company conducted a survey into the earnings of their employees. The information is shown below. Draw a histogram showing the data and estimate how many employees earned more than 48,000. So first of all, we need to work out our class width. Now it's nice easy groups for us here. So this one's going to be 15 take away 10. It's going to be 5. 15 to 20 is going to be 5. 20 to 30 is 10. 40 take away 30 is 10. 50 take away 40 is 10. And 100 take away 50, the size of that group then is 50. So we then find our frequency density. Important wee bit here, you find frequency density. Again, if you look back at the previous page, but you should learn this and know it is frequency divided then by class width. So 11 divided by 5 is going to give us 2.2. 34 divided by 5 is going to give us 6.8. 42 divided by 10 is 4.2. 12 divided by 10 is 1.2. 7 divided by 10 is 0.7. And 10 divided by 50 is 0.2. We then need to plot this. So we're going along, our bottom is going to go, I guess, from 10 to 100. Going up the side, then we need to go as high then as 6.8. So it's a fairly handy sized shape we have here. I'll try to work out a little bit. And you can hopefully then kind of see the whole thing. So you see with 7 bars going up here, so we have our frequency density going up here, and then going along the bottom with 10. That's a fine, sorry, not bars, but squares or blocks. So let's get ourselves set up here. So obviously, nice thick line going along here, and we're going to go, we'll actually go then from 0 to 100 because I think then it should fit in. So 0, 10, 20. Notice the continuous scale. Notice I'm not going 0 to 10, 10 to 20, and so on. 50, 60, 70, 80, 90, and 100. Up the side. Maybe turn this sideways here just so we can see. Again, this then is going to be my frequency density going up the side. Trying to avoid these holes here. So I'm just going to write here frequency density. And it would be 0, 1, 2, 3, 4, 5, 6, and 7. And then going along the bottom, obviously, with salary and thousands. that's us there. So our first group, we're going to have nothing in the 0 to 10 bracket. That's okay, we shouldn't have any gaps in between, but we're fine. But in the 10 to 15, it's going to be 2.2, and then 15 to 20 is 6.8. I always like to start with the highest one. I feel like it's easier. So 6.8 is going to take me all the way up to here. So if I try and do in this end is 6.8. So that's that bar. And we'll go down from there to there. Hopefully that's okay. Our first one then is 2.2. So that would be here. Again, with these, always try and do them nice and heavy. I haven't done a great job there with that horizontal line, but I think we can pretty much see it. And that's okay. Next group then is 20 to 30, and it's 4.2. Next group is 30 to 40, and that's 1.2. So, give me a second here. Okay. Then my next group, 40 to 50, is 0.7. So that would be obviously 0.6 there. That's going to be 0.8, so halfway along here. And then the final group, which takes me all the way to the end, so it's the big long thin one, is 0.2. And that's going to go all the way from 50 to 100 because the size then of that group. And then bear in mind with this, it's not the height of the bars, it's the area of the bars that counts. So even though this one here, you can see, is the highest bar, this one here actually has a bigger frequency. So because there's more area in this than there is in this, you take a wee look, sure enough, that's 42, and then that's 34. Then we have to estimate how many employees earned more than £48,000. So I would, 48, you can kind of draw it on here if you wish. So my 48 is going to be here. And so it's going to be that cut off there. So it's going to be all of these people here, and that's going to be a fifth of this group here, if that makes sense. So I honestly think it's easier if you do it from the table. So if we look back up, we need all of these people here, so it's going to be 10, and then a fifth of 7. So if we write that up here then, 10 plus a fifth of 7, which is obviously 10 plus 1.4, which is 11.4, and therefore 11 people, I guess, is the closest then whole number, and that's what we're looking for there. Okay.